All right, this is day 11 classwork. I'm going to work through these real-world linear programming problems as quickly as possible, give you some extra practice so you can check your work. But I'm going to be going fast. So if you need to pause, rewind, do what you need to do. First thing we do is the variables. All right, this is about pies. I'm not going to read it. How many pies of each type should he make? What are the pies? We got cherry, we've got peach. So the variables need to be, X will be the number of cherry pies, and I'm going to let Y be the number of peach pies. Now I'm looking for constraints, limitations. Blah, blah, blah. Peach pie this, cherry pie that. Joe has 36 cups of sugar. That's a constraint. 36 cups of sugar. That's all he's got. So that means there's a sugar constraint. So I'm going to write that down. I'm going to say, hey, look, everybody, sugar constraint. All right, now I'm going to write that sugar constraint. In fact, I'm going to squeeze it in right here. 36 cups of sugar, that means whatever else happens, it's got to be less than or equal to 36. So now I'm going to scan the problem looking for everywhere they mention sugar. All right, each year he says a cherry pie requires 2 cups of sugar. Blah, blah, blah. Peach pie requires 3 cups of sugar. Okay, so those are the other 2 things that go with sugar. So the cherry pie was X, peach is Y, so that's going to be 2X plus 3Y. So the sugar constraint is 2X plus 3Y is less than or equal to 36. Now I'm going to look for another constraint. It's probably near the first one. He has 36 cups of sugar and 20 sticks of butter. Guess what? 20 sticks of butter, that's another constraint. Okay, 20 sticks of butter. So now I'm going to look through the problem for everywhere they mention butter. Blah, blah, blah. Cherry pie, 2 sticks of butter. Peach pie, 1 stick of butter. All right, so look at this. 2 sticks of butter, 1 stick of butter, total 20 sticks of butter. Okay, let me use red this time. So this is a butter constraint. Okay, so 2 sticks of butter, so this is going to be 2x plus y is less than or equal to 20. So 2x plus y is less than or equal to 20. And then there will always be the reality constraints for a problem like this. Okay, reality. And the reality constraints are it can't have negative pies. So x has to be greater than or equal to 0, and y has to be greater than or equal to 0. So those are our 3 constraints. Now we need to work them and graph them. So looking at the blue one, you know, I've got that 2x plus 3y is less than or equal to 36. I could subtract 2x from both sides, so that gives me 3y is less than or equal to negative 2x plus 36. I need to divide by 3 everywhere, so that's going to look like this. So that's going to give me y is less than or equal to negative 2/3 x plus 12. Okay, so this is one constraint, and I'm going to go ahead and graph it. All right, 12, that's looking like a small enough number that should fit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Down 2 over 3. So down 2 over 3. I'm working it, I'm doing it, I'm living it, I'm loving it. Okay, so that's gonna look, whoops, I missed. I hate it when I miss. So that's gonna be like this. Let's make it blue, and let's make it a little bit bigger. This is less than or equal to, so I'm gonna put the grass, that little bit of shading, on the below side of this line. Just enough to remind me to stay on this side of the line. As long as I'm here, I might as well shade in the reality constraints as well. All right, the reality means we stay on this side of the line, of course, and we stay on this side of the line. Okay, this grass represents my reality constraint. Now the butter constraint. Let's do that butter constraint. Let's do it in red. So that constraint went 2x plus y is less than or equal to 20. Subtract 2x from both sides. That gives us y is less than or equal to negative 2x plus 20. All right, 20 is kind of a big number, but this goes up to like 23, so I'm still okay. Okay, whoa, where did I go? Where did everything go? Scary. Okay, so this one is at 12, so 13, 14, 15, 16, 17, 18, 19, so close. All right, that's 19. Had to mark it. So that's 20. That's 20. So then the slope is negative 2, so I'm going to go down to over 1, like this. Okay. I'm going to draw that line. I'm going to make it red. Okay. And this is once again a less than or equal to situation. So I'm going to put the grass on the underside, the below side of the line, to remind me to stay below this line. All right, so you can see that the feasible region is going to be in this area right here. Okay, I'm going to go ahead and try to use a polygon to represent that. Okay. We need the vertices. Okay, and the vertices are here, 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 and here. All right, 4 vertices. So the vertices are 0, 0. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So this is 6, 8. And this, I think, was 12, right? 2, 4, 6, 8, 10, 12. All right, so this one was 0, 12. So those are the 4 vertices. Now we need to substitute those into our objective function, but so far we haven't written the objective function, so we need to do that. So what is our objective? To maximize profit. So we need a profit equation. So the profit equation is going to run like this. Okay, he makes $5 for each cherry and $4 for each peach. All right, that's pure profit. So that's 5x plus 4y. So when we make our profit equation, it'll look like this. Profit. $5x plus 4y. So we will just take our 4 points one at a time, substitute it in. So if I put in 0, I get 0. I'm going around the clock, clockwise. So next 0, 12. If I put that in, all right, that obviously that's nothing, so that's 48. All right, next I have 6, 8. I'm doing this one. That's 62. And finally we have 10, 0. So it's 5, 10. 5 times 10 plus 4 times 0. So that's 50. Okay, so our max is right here. Max of 62. At that point right there. And let's just write that down before we move on. So we had a max of 62 at 6, 8. And for the record, we had a min of 0 at 0, 0. So summary statement. Hey, where's my text box? All right, this is a person, Joe. Joe is the Pi King. Okay, notice that I'm going to mention all 3 of these numbers, the 62, the 6, and the 8. For maximum profit of $62, Joe should make 6. Now let me just make sure about the variables. All right, cherry pies and then peach pies. Okay, so cherry peach. So 6 cherry pies and 8 peach pies. Okay, 6 and 8. Boom. Done. All right, that is how you do that, my friends. Okay. That was number 1. Let's look at number 2. All right, desks. 2 different kinds of desks. Blah, blah, blah. What's the maximum profit he can make? Okay, hold on. Okay. So it's saying what's the maximum profit he can make. That's something we always answer anyway. But okay, he's got the 2 kinds of desks. So we're gonna have to figure out how many of each kind of desk he can make. It doesn't actually, I was looking for it here at the end like it normally will say, but this time it didn't actually say how many of each type of desk. It just went straight to the profit question. But we still have to know that the variables will be the number of each type of desk. So this one's a little tricky in terms of defining your variables. All right, so two different kinds. So we have model A and model B. So I'm going to let X equal the number of models A, and I'm going to let Y be the number of models B. So, time for the constraints. Let me back it out just a little bit. So let's see. Model A brings a profit of this. There are only 8 hours of assembly time. That's a constraint. Only 8 hours of assembly time. That tells me I'm going to have an assembly constraint. So I'm going to go ahead and write that down right now. Assembly. Okay, maybe I can just squeeze it in right here. Only 8 hours. That means whatever else happens is going to be less than or equal to 8. So since we're talking assembly, I'm going to scan through the problem and looking for every mention of assembly. Model A takes 2 hours of assembly. Blah, blah, blah. Model B takes 1 hour of assembly. That's the rest of my inequality. So that's going to be 2x plus y. So 2x plus y is less than or equal to 8. Let's look for another constraint. 12 hours of painting time. There are only 12 hours of painting time. That's another constraint. All right, so I'm going to have a painting time constraint. I'm going to put that one in red. Okay, all right, only 12 hours, so that means less than or equal to 12. So now I'm going to scan through the problem looking for every mention of painting time. Model A takes 2 hours of painting time. And I'll just leave it blue because we know that that's painting time. And model B takes 3 hours of painting time. So that's 2x plus 3y. So that's my painting constraint. Don't forget your reality constraint. We cannot have negative desks, so x has to be greater than or equal to 0, and y has to be greater than or equal to 0. All right, let's work the constraints and graph them. Let's start with the assembly that I've shown in blue. All right, we have our 2x plus y is less than or equal to 8. Subtracting 2x from both sides gives me y is less than or equal to negative 2x plus 8. I'm going to go ahead and graph that. All right, so it's 1, 2, 3, 4, 5, 6, 7, 8. Just put a little 8 here to remind me. And this is down to over 1, like this. Whoa. I wish it wouldn't do that. Scares me. This is less than or equal to, so I'm going to put that little shading like grass growing upside down. Okay. There's also the reality constraints. Are like this. So far I have to be in this triangle, whatever else happens. Let's look at the next constraint, the painting constraint, which goes 2x plus 3y is less than or equal to 12. If you subtract 2x from both sides, that's going to give me 3y is less than or equal to negative 2x plus 12. If I divide everything by 3, that's going to give me y is less than or equal to negative 2/3 x plus 4. So 1, 2, 3, 4. All right, for my y-intercept, and then down 2 over 3. So down 2 over 3, down 2 over 3. Less than or equal to, put the grass on the bottom side. I don't even need to finish with the grass over here because I know I can't come out of the triangle, so sometimes I skip it. So you can see that this little quadrilateral right here is going to be my shaded area, my feasible region. Now we need those vertices, which are here, 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 and here. So that is 0, 0, 0, 4, 3, 2, and 4, 0. So those vertices need to be put into our objective function. But we haven't created that yet, so we better go back and check it out. Our objective is profit, so we need a profit function. I'm going to do the profit in pink. Maximum profit, okay. Model A brings a profit of $600 per desk. Model B, $400 per desk. So that's going to be 600x plus 400y. So let's write that down. Okay. Profit. P equals 600x plus 400y. And into that function we will put...
Just a reminder, the testing committee will meet in the PCR at 7:40. Testing committee, PCR 7:40. Thank you.
Okay, 0, 0 goes in. Whoops, 400. Okay, that's going to give me 0. Next, I'm going to do 0, 4. Okay, that's going to be 1,600. Next, I'm going to do 3, 2. It's 2,600 and 4, 0. So that's going to be 2,400. So we have a winner. 2,600 is the max, and it comes from this point right here. The maximum equals 2,600 at 3,2. This is not optional, by the way. Make sure you write this down. The minimum equals 0 at the 0,0. All right, and finally the summary statement. All right, is this a person or just some random manufacturer? Okay, so for a maximum profit of $2,600, they should make 3 model, it's model A, model B. Yeah, so for a maximum profit of $2,600, they should make 3 models A and 2 models B. All right, that is the end of number 2. I'm gonna end this recording here, and if I have time, I'll make a separate recording for number 3 and number 4. But I'm running out of time, so we'll just have to see.